Hello everyone, and welcome to Chapter 1, Introduction to Switched Networks. The objectives of this chapter are talking about a switched network in a small to medium-sized business, and talking about the process of frame forwarding inside the switched network, and lastly, getting down the important terms of collision domain and broadcast domain. Those are things you're likely to see on your final exam. So the hierarchy in a borderless switch network is real important. The hierarchical, modular, resilient, and flexible. These are terms that we're going to see that every network has to be actually, and switches can provide a lot of it in the way that they are managed and configured. Switches weren't always configurable, but switching is really the part of a network that's evolving fastest now because of the many different things that can be done to enhance a network's performance using the switch's configuration. In any network, you might recall, or if you haven't heard, this is very important. We use three areas of the network called the core, distribution, and access layers. The core is at the very center, where the routing and switching happens at its fastest. In this particular diagram, we have a central building and a data center routing and switching data between networks very quickly, and it's not inhibited by a whole lot of policy management, which makes switches work slowly. The distribution layer are bigger switches and more sophisticated switches than are not quite as big as the core, but certainly sophisticated, and we can put our policies on there. Who gets who gets what traffic inside of switches and routers and what can be allowed. And then at the access layer, that is where the users, like you and I, access the network. That's generally the first routing closet on the other side of your computer. The access switches bring us into the core, the distribution in the core. Now, not all three levels exist in every network. Sometimes a small business might just have an access and core layer with the distribution and core combined. So, as I mentioned before, the role of switched networks has evolved significantly. Switches used to be very simple, deciding whether to let a packet pass or not, but now they can be managed. Traffic can be prioritized in a feature we call quality of service, or QoS. It can also do wireless. It can provide security. All kinds of services can be added to switches now that weren't possible just a few years ago. On the physical side, we have switched form factors. The fixed type are what come with the switch. You can't do much about them. But the modular type, you can make some changes. You get a basic chassis, and you can add varying amounts of switch ports. You can even add modules, like one called an RSM, which is a route switch module, which isn't quite a router, but it can switch between virtual local networks, local area networks, and it plugs into the backplane of the switch, making the traffic changes exceptionally fast. And of course, on the end are stackable switches by a special cable that, when they're serial linked together like that, they're pretty quick. You don't see too much of that anymore. Now, the basics of how a switch works, we talked about a little bit in the last chapter, the last course. A switch works at layer 2, it reads MAC addresses, and the switch keeps a LAN table determining whose MAC address is out which port. And then when a packet has a destination for a certain MAC address, the traffic is only allowed out the port of its destination and doesn't flood all the other ports, making the network enormously more efficient than the old hubs of the old days where all the traffic went out to every port. So, LAN switches take the frames based on, remember, the MAC address. The MAC address, layer 2, that's where switching happens. Switches are layer 2 devices. Now, I think we've been through some of this. We have the switch has to learn devices, where it is before it can transmit the frame. So when it starts up, it floods all the data out all of the ports, and then those devices and hosts respond with a MAC address. And then the switch takes those addresses, matches them to the port they're in, and puts them in a memory table, a content addressable memory. That's kind of the connection between hardware and software that makes switching so fast. All right? So once that memory is used, the information in the table can send the frames with no more flooding is needed. When a new device comes on, the switch understands where it is, and often now we just have one device at the end of each port, but sometimes we still have star arrangements where a hub might be out, or there could be some kind of star topology where 3 or 4 devices come into one hub. The way switches forward, there are 2 types, and in this graphic you can see the store and forward is the most reliable, but takes a little bit more time. The benefit of speed has a cost of reliability in this case. So it looks through the entire frame, and then when the frame checksum, or the CRC, the cyclical redundancy check, if it matches and it's a good frame, it gets passed along. That's a very reliable way to do it, but even the time of reading those extra frames can take quite a bit. So there's another type called cut-through switching. And cut-through allows the switch to start right away, 10 microseconds. It doesn't do an FCS check. That saves the calculation time. It just reads the first couple of bytes and determines, and that's in the frame header, so it knows which MAC address it's going to. But it doesn't really care if the rest of the frame is either too large or too small or complete. It doesn't run the CRCD, so it sends it. So you may be getting some bad frames in, but it figures the other layers of the OSI model can handle that. Now for the important topics of collision domain versus broadcast domain, remember a collision domain is a segment where devices communicate in a switch. Every port on a switch has its own collision domain. By collision domain we mean if 2 devices are on one cable, they both send signals and those signals can collide. That's the area where those collisions can happen, is a collision domain. Now in older networks with hubs that went out 12 different directions, the entire local area network was a collision domain, and collisions ate up 80% of the bandwidth. Now that the price of switches has come down, switches can take each segment and break it into its own collision domain without any competition, and then their communication can be much more reliable. So a switch takes one big collision domains and breaks it down into many more little collision domains. There are more domains, but they are smaller and more reliable. Sometimes you see that trick question that a switch reduces collision domains. Well, it reduces collision, but it does that by building more domains. So keep that in mind. Broadcast domains are the same thing, but with a router. A router can, remember, a switch floods everything out of its ports when a broadcast address comes through. But a router does not forward broadcasts. So if a packet's destined for everybody, it stops at the router, because we don't want the internet full of broadcast commands. So a broadcast domain is generally anything on the inside of a router interface, including the switches, because switches do not limit broadcasts, usually, if that's how they're, out of the box, that's how they work. You can configure them otherwise. So, even if switches are connected together, the broadcast will forward to the other switch and then out all of that switch's ports as well. But of course it won't go out the port that originally received the broadcast, otherwise we'd have a spanning loop. We'll learn about spanning tree later on. So, switches alleviate network congestion by giving full duplex between devices, so plenty of communication bandwidth. Buffering large frames brings them in and lets them all get caught up. High-speed ports, fast internal switching with the content addressable memory we talked about. Okay? And also cut-through switching can be another way to make it fast. So I have made my way through this lecture briefly so that we can spend more time in the labs. I'll try to do that this semester. I hope. Now this is an abbreviated version of the lecture. I will put all the PowerPoints in the chapter materials for you to look at as you like. All right, see you in class.